All right, before we move on to the last part, there is a helpful rule of thumb. The acronym is ILATE or ILATE, whatever you want to use, on how to choose what to make U equal to. Okay, so this is some pretty intense Calc 1, Calc 2 study aid. So ILATE, you first look for inverse trig functions. L, you look for log functions. A for algebraic functions such as x squared, x cubed. T for trigonometric functions, and E exponential functions. Okay, ILATE. And if you look back at the 5 examples we did use this. All right, last step. If you recall the integral from problem 2, the integral of x cubed e to the x dx, this was our result. Kind of follow what we did. We basically did the same thing over and over and over again until the derivative of x cubed was 0. So look at the result. Let's follow the x cubed term first. X cubed, you go through all the derivatives of x cubed. X cubed, 3x squared, 6x, 6, and then 0, right? Presumably. That's why there's a plus c. And then look at what happens to e to the x. You go through all of the integrals of e to the x. The first time you integrate it, you get e to the x, e to the x, e to the x, e to the x, and so on. And then the signs change. You start out with a positive because the first time this appears is just uv. Then you're subtracting, so it goes from a positive to a minus, a positive to a minus. Okay, there is a way to do this in a more systematic way. So in the cases where you choose your one function to be u, and the nth derivative of u is 0, so it doesn't matter. This can be x to the 10th. Just eventually the derivative of u is 0. You can use something called tabular or table integration. First, you list u and its derivatives, then you list dv and its integrals, and then you alternate the signs. So you list u, so let's say u is represented by a function f and its derivatives. Then you list dv and its integrals. So the first thing you list is dv, like e to the x and its integrals, and then alternating signs, plus, minus, and so on. The only thing you have to remember, and then you multiply them across the columns. The only thing you have to remember is the arrows don't go straight ahead across, because if you remember in the integration by part, the first product is uv. So you're taking u and you're not multiplying it by dv, but you're multiplying it by the integral of dv or v. That's why the arrows are kind of pointing diagonally, okay, all the way until you come down to 0. Problem 6, find the indefinite integral x to the 4th times e to the x over 2 dx. So judging from problem 2, we're going to have to do integration by parts 4 times. Let's say we don't want to do that. Let's use our table or tabular method, okay. So u and its derivatives, dv and its integrals, and then alternating signs. Okay, so u and its derivatives, x to the 4th, 4x cubed, 12x squared, 24x, 24, and then 0. You stop when you get 0. dv and its integrals, this is a little tricky because it's not e to the x, it's e to the x over 2. E to the x over 2, 2 e to the x over 2, 4 e to the x over 2, 8 e to the x over 2, 16 times e to the x over 2, 32 times e to the x over 2. Alternating signs, plus, minus, plus, minus, plus, minus. Okay. Okay, so let's state the results. Positive x to the 4th times 2 e to the x squared minus 4x cubed times 4. The signs are related to the first column. It's kind of listed weird here. 4x cubed times 4 e to the x over 2, and so on. You multiply it until 24, and you follow the signs. All right, and then you can multiply the coefficients. So this is the result. This would be a little bit tedious if you had to do integration by part 4 times. So this can be used whenever you have a polynomial times literally any functions whose integral is a closed form formula. I do have one more example, and this just, it kind of seems like you should be doing some sort of a fraction division or something, but because this can be thought of as a polynomial times 1 over the 5th root of 3t plus 2, you can actually do tabular integration, or you can try. All right, so u and its derivatives, dv and its integrals, and then alternating signs. U is 12t squared plus 36. Its derivatives are 24t, 24, and then 0, and then you go from plus, minus to minus. Rewrite that 1 over 5th root of quantity 3t plus 2 as 3t plus 2 raised to the negative 1/5. And the integral is actually easy. You would just do U substitution. So you add 1 to the power, all right, you get 4/5, divide by 4/5 or multiply by 5/4, and then the 1/3 comes out from the U substitution. So those are the integrals of dv. All right, and then so the integral of our original integral, if you actually write it out, you get something like that. I don't think there's a way to simplify it. You can try to factor out the 5th root of 3t plus 2, but I don't think that's going to make it look simpler. So, didn't want to give you too many examples. I kind of gave you one of each type that you would see in Calc 2. Integration by parts is a Calc 2 topic. Now you're ready to work on a problem set for this lesson. I put in some routine problems and just some tricky ones like I did on the last set. The problem set is due next B-Day, in quotes, or on April 1st, 2020 at 10 a.m. Have a wonderful morning.